Hey everyone, and welcome to my YouTube channel. In today's video, we will talk about a very important topic of statistics, and that's an outlier. We'll talk about what is outlier, how to find an outlier, what is good outlier, what is bad outlier, what to do in case of having an outlier, and most important thing, the mathematical derivation of finding an outlier. So let's start with the video. What is an outlier? Outlier is something like, odd man out. If I have to just say, odd man out, that should be enough for an outlier. For example, let's say we have a group of people in a particular batch, right? And their ages are, let's say, 20 year, 25 years, 30 year, and someone is of, let's say, 75 years, right? And then we have, let's say, 22 year, 23 year, and so on. You can clearly see we have an outlier over here, which is 75. 75 is something which is not fitting into the, into the series that we have, right? You can generalize this as well. Like for example, I'm taking a class for data science, right? Usually I would expect people between the age of, let's say, 20 years to 30, 40 years, right? People with 75 years, it's not making a sense here unless and until he or she is doing this for their hobby, right? So this is basically your outlier, right? Now, let's come to the second point of it. Why it is important to detect an outlier, right? If you are building some machine learning model, right? Or even if you are doing some statistical analysis, identifying and solving for outlier is very, very important. Let me tell you the reason behind it. Let's say there are 5 people in a group having the age like 2 years, 3 years, 4, 5, and 6 years, let's say. What will be the average? Average will be 6 plus 5, 11, plus 4, 15, 18, 20, divided by 5, that's 4 years. Now, consider the same group, but having with an outlier, having age 2, 3, let's say here we have 40, 5, and 6. What will be the average age now? Average age will be 5 plus 6, 11, 51, 54, 56. 56 divided by 5, that's around 11.2 years, right? Think about it now. Just because one value got changed, 4 to 40, see the average change in the data. So that's around close to 3, right? Close to 3. 4 3 are 12, that's 11.2. So it's pretty much close to 3 times. So just because of a single outlier, your entire statistical properties got changed. And that's the issue with having an outlier, right? Now, if in place of average, if we take the median value, let's say what happens. So median is nothing but the middle value, but your data should be arranged, right? In ascending or descending order. Means your data should be sorted. So this data is already sorted. If I take the median of this will be how much? This will be 4, right? And if I take the median of this, I need to first arrange my data. So that will be 2, 3, 5, 6, and 40. So median will be 5 here. This is your median, correct? So now, at least if you take the median, the values have been changed very slightly. And that's why when you have outliers in the data, we prefer using median over mean or average, right? Now, let's quickly talk about how to identify an outlier. So for that, we will take an example. We'll take any random value. I'll give you a very good data to work on it. So let's say my data is something like this. It's 5, 7, 10, 15, 19, 21. Again, let's say having 21, I just have a number. So I'm just putting that number here. 22, again 22, 23, 23. Let's say 23 having 5 times, 4 and 5, right? Then we have 24, 24, 24, 24, and then we have 25. So total how many number? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, and 19, right? So total there is a 19 number. There are 19 numbers, right? Now, let's say I have to find the outlier. So before that, let's quickly talk about how to find an outlier, right? So if you guys have gone through a chart called as box plot, you must have seen box plot talking to you about an outlier. How a box plot look like? So it will be typically looking like this, right? Here you will be having this structure, and this will be basically your median line. So ideally, we expect that this is your quartile 1 and this is your quartile 3. We'll talk about all of this. Ideally, we'll expect that between this range to this range, our 25% of the data should lie. So let's say if you are having 500 records in your data set, I would expect that 125 record will be in this region. Between mean to the lower limit, I should have how much? That will be 50% of your data. So 250 records should be in this region. Till quartile 3, I should have 75% of your data, right? And that will be some, this will be 125, 250, and that will be 375 records in this region. And finally, till this particular point, the entire one, I would expect to have 100% of my data, and that's 500 rows. Now, this is my expectation. The real scenario might be different. How the real scenario would be? It will be like I might have certain records out, above this, or I might have certain records below this. Because if there is anything between this, that's not an outlier. That's the accepted distribution, right? So anything above this particular line or anything below this particular line, these are called as outliers, right? These are called as outliers. So next question is how you will detect these limitation or these boundaries. So for that, what we have to do is we have a formula, right? And what's that formula? So we say that anything below Q1 minus 1.5 times IQR, anything below this will be your outlier, and anything above Q3 plus 1.5 times IQR will be also an outliers, right? Now, what is this IQR? IQR is called as inter-quartile range, and this is nothing but Q3 minus Q1. So in order to find the outlier in my data set, I need to find first what is Q1, what is Q3, what is IQR, and then I'll put on the values to find what is an outlier, right? Which of these data points will be an outlier. So before that, let's quickly find out what is the median values of it. So this data set is having 19 records. I believe the data set is already sorted. So the median values will be the middle one, right? So that will be, I think, 10th value. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Right? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So this is your median values. Right? Now, what will the quartile one? Find the median value from here. So 1, 2, 3, 4, 5, 6, 7, 8, 9. 9 values we have, right? So fifth value, 1, 2, 3, 4, 5. This is your quartile 1 value. Similarly here, 1, 2, 3, 4, 5. This is your quartile 3 value. So now we have median value, that's 23. We have quartile 1, that's 19. We have quartile 3, that's 24. What will be the IQR? IQR will be quartile 3, Q3 minus Q1, that's 24 minus 19, and that's 5, right? So IQR is nothing but 5. Now find out the values. How much this value will be? So Q1, that's 19, minus 1.5 times 5. That's 19 minus how much? 7.5, and that's 11.5. So we can say any value below 11.5 will be your outlier, right? Any value below 11.5 will be your outlier. So how many outliers we have? Below 11.5, we have basically these three values, 5, 7, and 10. So 5, 7, and 10 are your outliers. Similarly, if I go to this one, that will be like, Q3, that's 24, plus 5 times 1.5, that's 24 plus 7.5, this is 31.5. So any value above 31.5 will be an outlier. We don't have any value of 31.5, and that's why we don't have any upper outlier. So in this particular data set, we just have lower outliers. There are 3 lower outliers, and those are 5, 7, and 10. This is actually same thing happens when you create a box plot in Python or R or any other, data visualization tools and languages, right? So that's what we call it as an outlier. I hope you got a very good grasp of how the mathematics works behind an outlier. If you want to, do an exercise, I'm just pasting one data series, and you can maybe, do exercise to create an outlier. So let's say I'm having the value like -19, -1, 0, 5, 7, 9, 12, 12, again 12, then 13 and 13. So whenever you get some time, try finding, do we have any outlier in this data series or not, right? So that way you can create, create the outlier, understand how it's working. Now let me quickly tell you what is good outlier and what is a bad outlier. So let's say we have, an example of let's say temperature of certain place, right? So let's say you got the temperature like 22 degrees centigrade, right? 35 degrees centigrade, you have 40, you have 19, you have 12, you have 95 degrees centigrade, you have, let's say, 14 degrees centigrade, and so on. We have certainly an outlier here, right? And that's nothing but this 95 degrees centigrade. Now, if I have to identify whether it's a good outlier or a bad outlier, there are a couple of very small assumptions that you can make. First, whether this value is possible, right? Definitely 95 degrees centigrade is not at all possible. So this is not a good outlier. This is a bad outlier. And second assumption will be, if at all this value is possible, right? What, whether this is giving you a further opportunity of analysis or not. If the answer to both the question is yes, then you can consider it as a good outlier. Now, at the same time, let's take an example of, the cash injection in an ATM or the ATM withdrawal, transaction withdrawal, data set. You have the withdrawal values like 100, let's say 200, 300, 500, or 400, 600. Then you have, let's say, 20,000, right? Then you have, let's say, 700, and so on. Again, we definitely have an outlier, and that's this 20,000, right? But now let's understand whether this is a good outlier or a bad outlier, right? So first, is this possible? Yes, at least in Indian ATM, you can withdraw 20,000 in a single limit, right? So definitely it's possible. Second is whether this is giving you an opportunity of analysis or not. Think like this. Let's say you are doing some analysis, understanding like, how much cash you need to pay or you need to keep in an ATM in, let's say, in rural areas, right? So basically you have to do certain cash analysis. Think like this, guys. Think like this. Let's say on an average, there are, 100% visiting that ATM on a daily basis. On an average cash that they withdraw is 200 rupees, right? So what will be the total amount in a day? That will be like 20,000, correct? Or let's say this is 300, right? For the simplicity, let's, and to depict the good value, let's say this is 300. 300 is the value that, 300 is the amount that they withdraw on daily basis. So basically 30,000 will be the cash withdrawal from that particular ATM, right? So I can say if I am putting 30,000 rupees on a daily basis to that particular ATM, there won't be any people who will be getting the message like cash not available, right? On an average, 100 people, 300 rupees is the average transaction per withdrawal. Now think like you have an outlier in a day, right? So that particular person is withdrawing 20,000. So that person came, withdrawn 20,000, you had 30,000 in the ATM. How much you are left with? You are left with only 10,000. 300 rupees is the average amount that people withdraw. So how many people you can serve with this, 10,000? That will be, I believe, 33, little more than it, right? So this 33 plus 1 who withdrawn 20,000 is 34. So with this 30,000, you are only able to serve 34 people that day. What about remaining people? So 100 minus 34, that will be like how much? 66, right? So 66 people coming to that ATM to withdraw the amount will be getting the cash not found error. So see, just because of your single transaction, 66 people are having bad impression about the ATM, and none of the bank would like to have that, right? And that's why this kind of analysis is very important. So you can understand the further behavior around such kind of high withdrawal, whether this is happening once in a moon. If it's once in a moon, you cannot do a lot of things around it. But if it's frequent, maybe like, once a day, once a week, twice a week, so you have to adjust that outlier in your analysis so that people are not getting the, cash not found messages, and they are not having the bad impressions around it. So that's the power of an outlier, why it is important to treat an outliers, etc. So in this video, I'm just summarizing it. We talked about what is an outlier, why it is important to handle the outlier, how it changed the statistics of your data. We did the mathematical derivations to find an outlier, and then we talked about what is a good or bad outlier and how a bad outlier or a good outlier might impact your overall business statistics. I hope you liked this video. Please subscribe to our channel for such content, and let me know in the comment box if you enjoyed it or if you have any questions. Thank you.